Thanks very much, Adam. Great conference this year. Enjoyed the first day, and as usual, learned a lot from the speakers you had. So thanks very much. Great opportunity to participate here in day two. We've got a very interesting panel on predictive maintenance today. We've got representatives from Norway, India, Italy, Brazil, and the UK. So very international, and hopefully we'll get some good insights from our speakers today. So we're going to kick off with Fabrizio de Antonio, who's the asset integrity manager from Raffineria de Milazzo in Italy. He's got a short predictive maintenance case study to kick us off after he introduces himself, and then we'll introduce each of the other speakers in turn. So Fabrizio?
Thank you very much for inviting me to speak to this event. I'm Fabrizio D'Antonio. I'm the Asset Integrity Manager at Raffineria di Milazzo. And it will be my pleasure to do this presentation on a system that we have implemented, a custom program that we have implemented at Raffineria di Milazzo. This is a system which intent is to monitor the creep in all equipment that undergoes creep conditions. So we did this custom program that continuously monitors vessel and piping that is working in creep. The program is online, so the extraction of the temperatures of the data is the temperature the equipment is undergoing. The first thing we have to a short recap to the creep phenomenon. When we have metals subjected to stress, we also have a deformation. This deformation is proportional to the stress. If we exceed the temperature at which creep starts, even if the stress remains the same, the deformation increases. So there is a primary stage in which the speed is reducing, then a very long stage, normally a long stage at which the speed of deformation is constant, and then the tertiary stage, which is dangerous because the speed increases, and we eventually go to the rupture, and so it is a very bad event, obviously, for the refinery, for the system. So normally there are control bodies for all creep or equipment that undergoes creep, and the way to normal control is just counting the running time. So if the plant has been during a year running for 8,000 hours, we just consider 8,000 hours time. But this is normal, but I think that a more accurate control can be helpful, since we neglect if there are over temperatures. We don't do anything to recognize them and to take in account. So it is good to, in my opinion, to control better control. In the design of the creep subjected equipment, we introduced the T-creep, which is the temperature at which the creep starts. We normally have a design temperature, which is a temperature at which, after this design number of hours, the material is expected to fail. 100,000 hours is the normal design time. And the temperature and the design time is this 100 time 100 hours. In the study of the creep subjected equipment, we introduced this parameter, and which links the constant, which is proper of the material and the temperature and the design time, and it is depending on stress. We can see the higher the stress, the lower is the Larson-Miller parameter. In the calculation of the creep time, we use from the Larson-Miller equation this formula. which is derived from the Larson-Miller parameter. And the equivalent equation can be used for other that have been studied by other researchers and can be used. We introduced the X parameters, which is 0 when the temperature is below T creep, is 1 when the temperature is between the creep start temperature and the design temperature, and is the ratio between the design time and the actual remaining time when the temperature exceeds the design. So if we had, for instance, 100,000 hours is the design time, and at the same time at this temperature we have 10,000 hours left because the temperature is higher, obviously the parameter is 10. So 1 hour is 10 hours according to creep consumption, let's say, to creep advancement. So we have an increased safety because obviously we consider 1 even if T is a bit less than T design. And I already said that when T is above T design, X is higher. And so we just need to integrate the X parameter to get the equivalent time spent at the moment, let's say. And that's what our program does. This is the simulation we did. We can see that this line, the blue line, is the creep temperature, the temperature at which creep starts. This is the design temperature. This is the simulation, how the temperature goes. We have 48 hours above, and we can see that no creep, 0, so no problem. Here we are starting to have creep, and according to the local bodies, we consider 1 hour for each hour spent in this zone. But here we have a problem because the time is accelerating. The creep is accelerating here, and then we go back to the normal situation. So in this simulation, we can see that the duration is of the over temperature. So the time at which the temperature is above the design is about 48. The peak temperature is 980 against the 950 design. And for this range, and we can see that in 40-hour temperatures with the integration of the X parameter, we have consumed 120 hours. So we can see that even if the over temperature are not so high, the time consumption is not negligible, let's say, is still important. So let's go to the conclusion. By doing this, we hope to have some advantages. So we will be able to control in a more precise, let's say, way the total hours in creep regime. We can estimate the impact of the temperature excursions because otherwise it is possible that we don't know that there has been a temperature excursion, because if you don't control, obviously we don't know. This is easily applicable to all equipment. We just need to know the temperature at which the equipment runs, and we get it from the DCS, as I said before. And we can also have, obviously, a good help in preparing non-destructive test control plans, because if we know that some equipment has had over temperatures, we can adjust. Thank you.
Okay, thanks very much, Fabrizio. Yeah, we wanted to start out with a little case study just to show an example of how gathering data during operations is able to help us do a better job of predicting our maintenance, understanding the service life, and how some of the asset integrity features might be influencing our facilities. So I want to hand over now to Harald Wesenberg with Equinor to give us an introduction and some of his thoughts on predictive maintenance. Harald?
Yes, thank you, David. And thank you for having me on this panel. My name is Harald Wesenberg. I am, as it says, an IT specialist and software innovator at Equinor, which is a fairly large Norwegian energy company. Equinor has been working with predictive maintenance for some years, and we're starting to see sorry, I think maybe you need to do one or the other. So I have a strong cough. Can you do that?
Sure. Sorry, I had a bug in my throat just a second ago as well. Renata from Lopes, Predictive Industrial Lead from Braskem in Sao Paulo. Welcome.
Hi, everyone. Good morning. I'm glad to be here, David. It's a good opportunity to exchange some experiences. I work at Braskem, and also, as Harald mentioned, we have been doing predictive maintenance there for a while. And especially in my case, I have been working with digital transformation for the past 4 years or so. And what we are aiming to is to develop customized platforms to predict any unwanted situations. So we are a little bit broader than just maintenance. We also aim to avoid or to minimize any process deviations that might cause mechanical failure also. And just a curiosity, because the success of these platforms, they are based on machine learning. So it all comes from the data quality that we have. So something that is being quite new in the maintenance area in Braskem is, besides taking care of our assets, taking care of our data. So this is something kind of new in the maintenance, and it would be also something that I would like to share experiences about.
Yeah, thank you. That's a good point. Data maintenance. We got to do maintenance on our facilities, but we have to do maintenance on our data as well. The garbage in, garbage out, getting data of the wrong fidelity, not getting the boundaries of our data for a particular piece of equipment. A lot of maintenance needed on your data. Good point. Deepika, Sandeep, AI lead of Honeywell in Bangalore. Could you introduce yourself?
Sure. Yeah. Thank you, David. And hi, everyone. Glad to be here today. I'm Deepika from India. So I'm currently heading the AIML division for Honeywell's Smart Buildings business unit. And here our focus is to leverage AI for three different outcomes, I would say, for improving the operational efficiency in buildings, for sustainability, and also for improving the alarm management, and also the bringing in automation in buildings using AI. So in a typical commercial building setup, there are multiple equipment that are installed, be it for heating, ventilation, air conditioning, fire protection and safety, access control, intrusion detection, and many such applications. And all these equipment require maintenance. And in the context of commercial buildings, we use predictive maintenance for these three purposes. That is the ones that I mentioned on operational efficiency, better alarm management, which will in turn help the operators as well, and also to bring in energy savings. Now, with remote monitoring becoming imperative, it is important that we spot the anomalies and catch the defects early, perform root cause analysis, and be able to take the right action at the right time in order to either completely avert the failure or at least to get some kind of a leeway to prepare for the impending failure. So that is the focus of predictive maintenance for us as well. And let me just quote a few examples on how we use predictive maintenance for buildings. And if we consider something like a fire sensor, so fire sensors are extremely prone to dust accumulation. And if we do not clean these sensors at the right time, we will end up with a lot of false fire alarms. And different fire sensors will require maintenance at different times depending on which environment they are installed in. And predictive and prescriptive maintenance solutions in these cases add a lot of value. And it's a similar case if we consider HVAC equipment. HVAC equipment are known to be energy hoggers, I mean. And if there are filters in HVAC equipment which are clogged, it will still work, but it will consume a lot of energy, much more than what is necessary. So in these cases, if we can identify these kind of anomalies and clean the filters at the right time, we will end up with a lot of energy savings in the long run. Yeah, so these are a couple of examples how we use predictive maintenance in the context of commercial buildings.
Yeah, thank you, Deepika. Yeah, that's great. So we actually have to do maintenance itself on the IoT devices. And we've got the ability to have virtual instruments, virtual devices to help understand if one guy starts having a problem, but also I guess in some critical applications, we can have multiple instruments so we can have voting. And so if one starts getting filled with dust or clogged or giving a bad reading, we can decide if there's still valid data from the other one. So Francesco Coletti from Hexxcell here in the UK.
Hi,
Over to
David.
you.
Hi, everyone. Yeah, my name is Francesco Coletti. I'm the CEO of Hexxcell Limited. For those of you who don't know Hexxcell, we're actually the predictive maintenance partner of the conference. We started working on predictive maintenance over 10 years ago, in particular on predictive maintenance of heat exchangers. Why heat exchangers? Because there is a lot of energy that is related to heat exchanger when the heat exchangers are not run optimally and they're not maintained properly. When we make cleaning decision choices, when we decide how to clean them, all these decisions are really affecting the energy efficiency of our plants, are really affecting the CO2 emissions related to that energy efficiency. And so there is a big impact that heat exchangers networks have on the operation. So we start a little bit different. We kind of have a little bit different angle here. We don't have a platform that is meant to solve every problem. We started from the problem, in particular fouling in crude distillation units and in other areas, cooling water fouling petrochemical plants, and we build a solution around that. So our solution really focuses on optimizing the cleaning schedules of the heat exchangers. And as I said, the reason why we do that is entirely because there is a lot of energy. If you look at the preheat train, for example, in a crude distillation unit, basically 60% of the energy and the CO2 emissions of the entire refinery are due to the heating processes in the crude distillation units. So where we can help there is to look at when we clean the heat exchangers, how we clean them. So going from a predictive piece, when to clean and which heat exchanger to clean, all the way to the prescriptive piece, which is often neglected when we talk about heat exchangers. We look at when to clean, but also how to clean. It's important. Should we always default to mechanical cleaning, or should we look at a different type of cleaning, chemical cleaning, ultrasounds? There are other options these days that can be considered. They might shorten the time the heat exchanger is taken offline. They might not require to dismantle the heat exchangers. So all these considerations are very much in our mind and very much need to be included, especially when we look at the ambitious net zero targets that we have set for ourselves and the government has set for ourselves. So if you want to make a big dent on the CO2 emission in a refinery, we should be looking at where the biggest energy consumers and the CO2 emitters are. This is really the crude preheat train, and looking at what can we do about it. And predictive maintenance has a lot to do with that. And so I think that's my message here. Predictive maintenance in heat exchangers has a big impact from a operational point of view, from a CO2 emission point of view, from energy point of view, and also from a production point of view, because very often we need to stop, clean, and it can create production losses, which is very significant for refineries and petrochemical plants.
Thank you, Francesco. We got a question from the audience about this topic. Susanna has asked us how to predict the required cleaning of the heat exchangers. What kind of data is showing you that you need to clean a heat exchanger?
Right. So our approach is, and I think I really thank Renata for bringing up the data quality and the data availability and so on. Yes, it's the reason the approach that we take is a hybrid modeling. Okay. I mentioned to Adam yesterday that I think we can safely claim that we are the first one looking at this problem in particular. We did not invent hybrid AI, but we are the first one developing hybrid AI approach for this type of problems. Why hybrid AI? Because relying on AI alone on heat exchanger data, it can result in wrong choices, right? So going back to the question, data that we need is temperatures, flow rate, and pressure drops. We typically use the available data. We develop the technology around the data in order to, and that's why the hybrid AI. So we have the deterministic model that allows to do data reconciliation. We can check the quality of the data. We can adjust the measurements if needed. We can provide soft sensors as well. Our models are thermohydraulic, right? So we look at the thermal aspects of the impact of fouling in heat exchangers, but also the hydraulic one, which is very much related to the production losses. So with that information, we are able to provide soft sensors, if you will, information on pressure drops, for example. So the data that we use are quite basic. Of course, the more the merrier. Of course, the better quality, the merrier. Of course, we always would like to have additional pressure drop measurements, additional temperature measurements, but it can be done with existing measurement. I think that's one of the advantages of predictive maintenance is that with existing measurements, we can do a lot, and we can do a lot today. Of course, they can be improved. Of course, we can do better, but with existing information that we have, we can do a lot. And we don't have to wait another 5 years, 8 years, 10 years for electrifying our heat exchangers or electrifying our furnaces to be able to meet our net zero targets. So it's something that we can really do today with existing data.
Okay, one of the things I always like to remind people as well is it seems like in the olden days we had heat exchangers for the cooling for the sake of cooling, but these days it's as important to harvest that heat to have a more efficient overall process. We want to get that heat out and go use it somewhere else, which helps us reduce our overall carbon footprint of the facility. So back to you, Harald. Can you introduce yourself and give us some input from Equinor?
Yes, thank you. Sorry about what happened, but it's one of these things. Yes, so my name is Harald Wesenberg. I work in Equinor. Have been working here for 27 years. And I work with IT innovation or software intensive innovation. Equinor has been working towards predictive maintenance or condition-based maintenance and not scheduled maintenance for quite some time. We have a lot of experience with it. And if you have been following the news, you might have seen that we did have this slight accident at Melkøya about 2 years ago now, which shows what can happen if your predictive maintenance is not able to predict properly. And although all of the others, and we completely agree, good data is the foundation of being able to do good predictive maintenance. But we're also starting to see that you have to do a wider risk analysis beyond the data itself. So we have to do a proper equipment risk evaluation. What does the data tell you? Where does the data come from? What kind of experience does the data have? Because it's a big difference between running a turbine or filters in the desert compared to running them in a much cleaner environment. But then on the other hand, you also have the topic that or the problem that you can get in some areas, which is that the conditions might differ wildly throughout the year. So the measurements on air quality and so on that you have from some part of the year might not be applicable throughout the year. And once you have a proper risk evaluation of the equipment itself, you have to do a proper system risk evaluation. So you have to understand how this equipment functions as part of a bigger system. This is also a interesting and complicated and complex topic. So we have found out that this is the area that we're trying to get better at. So if we're going to use predictive maintenance, we have to get better at evaluating risks and compensating and mitigating risks. And that brings us to a third challenge that we are seeing, and that is that when you're doing the predictive maintenance, and especially if you're focusing on the equipment, you're probably doing that with specialists at the equipment manufacturer and specialists within the company that is using it. But at the same time, in the plant where the equipment is used, there might be all kinds of silent deviations in behavior from operational procedures that you might or might not know about, that not only changes the way the equipment is used, but also changes the function of the equipment in the context of its system. And that is where predictive maintenance in our experiences can get quite difficult. So I think I'll leave it at that, and then we'll go on.
Well, I'm going to stay with you, Harald, on our topic of machine learning and AI. So we've identified that we want to do predictive maintenance. We've got data streams coming in. We've heard that we want to do maintenance on those data streams, on the IoT sensors themselves. Then the idea of doing some kind of advanced analytics using machine learning or AI. How's that working for Equinor?
Yeah, going back to what I just said is that it has a lot of useful cases. Machine learning and AI is, in my opinion, just simple statistics done many times and very fast, which is not meant to be talking AI and machine learning down, because it is very useful if you can reduce your prediction problem to a set of statistical problems that you can then solve for. But then you get into this topic of having enough data. Equinor has always been focused on having enough data, good data, and we have a lot of sensors in place all over our installations, both onshore and offshore, to capture all of the different data. And some of the data, some of the time series go back 30 years. So we have a lot of data to see on our equipment on how it has been behaving over time. But one of the challenges that we see with AI and machine learning is that you have to ensure that you have sufficient richness of data, and you have to maybe augment it with other kinds of data collections, because, for instance, there is no real substitute for an experienced operator going around and looking at stuff to verify what your AI and machine learning algorithms are predicting. And so you have to find that balance between good analytics that can give you a good hypothesis that you can test, but you have to augment that with people on the ground looking at things that you haven't thought about. Because one of my key tenets in this life is that you cannot use technology to automate rules that you don't know. And so you have to have this resilience in the form of humans that are actually working, actually inspecting, on top of whatever you do with technology, to ensure that you capture all of these things that you haven't thought about.
Yeah, I think that's a good point. We sometimes people focus on the statistical correlation without necessarily understanding what's physically lies behind that, and what physically would you want to change to get a different outcome. So just knowing there's a correlation doesn't really help the operator, and unless he knows, is something changing on the inputs? Does he need to change the settings on some of his equipment, some of his controls? So that operator's experience in the early days, we really need them there. Hopefully we can train up some of these AI models to start acquiring some of that information. Renata, I understand that you guys are having some good experience with preventive maintenance and AI for pyrolysis furnaces. I wonder if you could share some of that with us.
Yeah, we have other kinds of suppliers for predictive maintenance in Braskem, but this specific approach is what we call it. It's a customized approach because we follow the data that we have, the type of the data, and it's really interesting what Harald was just talking, because the human input will always be necessary, because the analysis of the data is a little blind, so you will always need the inputs from people to refine the tool. So for the pyrolysis furnaces, we have a tool that we can monitor the condition online, but also we can compare to predictions. So it helps the operators to maneuver the furnaces for the best time to shut it down and clean. Not just a predictive tool to tell you when it's the best time, but it gives you also inputs to manage how to make it longer or not, when according to the other factors that you have to keeping the furnace on or off. So it is a custom-made tool, and it's working very well. We have different types of furnaces in Braskem, so even the tools and the data, they are a little different. So we have different types of results. And what I would also like to add is since it's a custom-made tool, is not something, it's not a license that we buy from a famous supplier or something. We build it inside with software developers, data scientists. So it's also really important to have the commitment and engagement from the industrial teams, the operators, because it's something that we are building together. And in the beginning, it might not work so well. So we will be working on accuracy together. So this is also, I call it a cultural aspect, because it's not something that will work. It might work well at the first shot, but it's possible that it won't. So it's something that we have to work together. And sometimes this new technology is still scary, and people don't really understand, is this replacing me? Is this taking my job away? But no, as Harald said, it's something that can work, and it has to work together to leverage the results.
Yeah, that's good. Augmented humans, not just augmented reality, augmented humans. Deepika, with digital twins for asset monitoring becoming so widely used and everything, I was wondering if you have a view on the role of AI in this.
Yeah, so AI is at the core of predictive maintenance, and today we see that digital twins are being increasingly used for both design and operations of assets. And AI is more extensively used in the operational digital twins. So this would typically comprise of three different components. One, the simulation of the asset itself. Second, the analysis of the operational data that we collect from the assets. Third, a 3D visualization of the asset performance on a real-time basis. Now, AI can play a significant role when we face situations where the new installation of sensors becomes a challenge. And we very often encounter these kind of challenges in commercial buildings, and could be in other domains as well, for various reasons. So now today AI solutions are being used as proxy for explicit sensor measurements. So instead of having sensors installed newly, people are leveraging AI solutions for estimating and predicting these operational parameters based on other already available parameters. And this is adding a significant value to the existing greenfield projects, right? Or more like the brownfield projects. And the data quality, the data sanctity, the data sanity is extremely important. And in the case of IoT, we also see a lot of loss of data happening. So that is why digital twins today, like the way the other panelists also mentioned, uh, we are using a hybrid modeling approach, not only on AI. So hybrid modeling is a combination of the first principles based modeling and the data driven approach using AI. So when there is loss of data, this comes in very handy. So yeah, these are some of the ways digital twins are enabling predictive maintenance for assets, both from an energy conservation standpoint and gaining a greater visibility into the operations of the asset standpoint.
Thank you, Deepika. Fabrizio, machine learning, AI, advanced process control, is that being used in your refinery? Can you share some highlights?
Okay, yes. It is very important. Let's say we obviously have a lot of running machinery, and some of them are very important. So we are trying to extend our predictive maintenance, and we are also beginning to use artificial intelligence because we recognize that it is very important, since a few minutes in a bad operational mode can bring much more damage to equipment compared to months of normal run operation. So even if you do vibration monitoring, and it is not the same as having a model that can online that can tell you when the situation is going wrong quickly, and you can save a lot of problems. You can avoid a lot of problem with that. But as Renata said, it is also a question of cultural change that has to be understood, let's say, because what you get from this system, you have obviously to validate it, but has to be also accepted, let's say, because sometimes your system tells you you need some maintenance, but still someone is not, let's say, convinced that it's time to do that.
Yeah, there's an interesting statistic that something like 70 to 80% of maintenance is done at the wrong time. It's either too early and it's not needed to be done, or unfortunately it's too late. So getting the right, using these
Yes.
right tools to help us try to improve that statistic, which is a little bit awkward. Francesco, AI, machine learning, how does that factor into your work?
Yeah, and we come from a different, as I mentioned before, from a slightly different angle. So we started with from the deterministic world, rather than starting from an AI, having a hammer and trying to find use cases, right? We build models, and we go as deep as we can in the description of the physics. We're engineers. We like the deterministic world, and sometimes we are uncomfortable when the statistics comes in. Because of that 10% that might not be, that might not be in the right place. But we do add a layer of AI that helps the deterministic models to do their job better, to do their job faster, to capture things that they will not be able to know. And so I see it. I struggle to see, because of the discussion that we are having, because of the problems with the data, right? The data quality, the contextualization of the data. Because the reality of it is that when you go in the refinery or you go in a petrochemical plant, the data was collected 10 years, 20 years, 30 years ago, when we did not have in mind the Industry 4.0, we did not even know what predictive maintenance was. So once we need to use that data and you want to start using it today, you need to deal with the reality of that data. Now going forward is very good that we're having these conversations. It's very good that we're putting in place the data quality measurements to be able to use AI at scale. But the reality is that when you look at the past 5 years of data, 10 years of data, the quality of the data is not there. So you need to have, in our view, you need to have the deterministic model to support the artificial intelligence piece to do its job properly. It's more difficult to scale. Of course, if you have an AI model that works perfectly, press the button and it works, that's what helps you to scale. But the reality of it is that measurements are missing, quality is not good, and also going back to Fabrizio's point before, and Renata's point in terms of the acceptance from the user, right? It's not just the believing piece, especially, we have found customers that have been ramping up or ramping down the production of their refinery just to verify what we are saying, and they're incredible, but they believe us, right? I think we got past the point of believing only, which is a big piece of it, yeah. But it's also from a practical point of view, how close can the refinery really follow those instructions, right? So we say clean a heat exchanger in 1 month, right? How closely can they actually do? Is the budget there for that? Is the vendor available in those days? So the cultural thing is not just introducing the tool and having the users to use it, but also everything else that goes around it, which we never talk about too much, which is the practicality of the implementation of the solution that we are recommending.
Yeah. So you have some advanced analytics, and it tells you this pump is going to fail in 3 weeks. Now, do you believe it? And if so, what are you going to do about it, and how are you going to schedule that? And you would like that to be a very deterministic number, but of course it's stochastic. So it's going to fail sooner rather than later. Harald.
Yeah, I just wanted to build on what Francesco was saying, because one of the differences between having deterministic or traditional statistical models is that you can very often test them properly with known inputs in your laboratory or in your test environment, and so you have quite a lot of control of what goes into your production environment. One of the challenges that we see with some of these AI and machine learning models is that they continue to evolve in production, because that is one of the concepts of machine learning and AI, is that it's continuously learning based on feedback and inputs that it gets while it is running. But that also makes the model a lot more opaque and difficult to predict actual behavior, and it's not that I'm negative to AI and machine learning and so on, but you have to be aware of that aspect of machine learning, so that you build your monitoring around your models based on the fact that the model is changing while you're running it.
Yeah, that's a good point. Actually, even that even feeds back into the analytical design phase. Is we may have a deterministic idea of what our input and process conditions might be, but really there's going to be things that vary. There's going to be different scenarios that happen. Sometimes the hydrodynamic flow of fluids through things will give you different results than you might expect. So how you're able to factor that into your simulation models, and then once you start production, learning from that, is that actually behaving the way you analyzed it or not? Renata, we had a question from the audience, getting back to your discussion about which form would you contextualize field data with human experience, not only to get instantaneous insights, but also to predict, for example, overall condition decline, specific failures. So you get your data in, but your humans will know, okay, that means something that we need to start looking out for. How does that factor into your analytics, your machine learning, your AI systems?
Yeah, if I understood correctly, we are talking about how we interact the human experience and with what the data says, right?
Right. Right.
Okay, so that is the thing that I was telling before. It is we are building these tools together with the industrial teams. So we usually get all the available data from many different data sources, process it. So when we start processing that data, we need to constantly check with the operators, engineers, any specialists in that condition that we are modeling to say, does this make sense or no? And it is interesting because at the same time that we need their inputs to clean the data, so we take it out the things that make no sense, because the correlations sometimes are just it's spurious, they don't make sense, so we need to cut that out. But also sometimes the data will bring something new to the engineers, and that is interesting because it is a constant contact that we have, and it is interesting what Francesco said, because it's new. So it's not that they don't believe it anymore. I really like that we are on the same page in some aspects, because it's not something that people will say, no, that doesn't work. But when you show with the data to someone that has like 20 years of experience that there is something new about his job, about his activities that he's been doing for years and years, it is new, it's different, and sometimes that happens. So it is important to keep these teams together. We have teams from software engineering, data science, that they are not always so familiar with the industrial aspects, and vice versa. Some of the industrial people, they don't really understand how the data is managed. So I think the most important thing is to get those things together and try to make both go halfway, so they have a common language to talk.
That's good. Got another question for Deepika from the audience. It says, are you only looking at predicting the performance decline of the assets and equipment as a function of their intensity of use, or do you also help prescribe the intensity of use? So I guess that's, you've learned from what's happening from your stuff, now feeding that back into how humans interact with this, how you change things, climatic conditions, how people react to messages they get from the control system. How does that work?
Yeah, so AI typically would stop at just providing the recommendation. But what is of value is the control which comes after AI, based on the recommendation that is provided by the AI system. So any predictive maintenance problem we approach using AI, we try to answer these questions. That is, what is the problem? What is the root cause of the problem? What is the action that needs to be taken? And how do we take this action? So it's a closed loop control after the AI, which is actually more valuable than just stopping with AI. So does that answer your question?
Yeah. Fabrizio, I'll give you a question from the audience here. Let's just look through the questions here. As you've used these systems, does your confidence build from your operators that they can actually believe these analytic systems, the data that's coming in and the recommendations that come from that, how people need to change settings when the slate of your product changes and you need to make other changes? How do you
Yes.
build the confidence of your operators that the data is giving them stuff that they should react to properly?
Okay, I would like also to link to one of the panel one topic that was crude allocation and scheduling, because this is linked, I guess, because at the moment in the refineries we have faced very, very hard times in the last years. You obviously everybody knows, and the opportunity of having, let's say, crude that could give you better margins was very important. But obviously, this also gave danger, because normally these crudes can introduce very important changes and increase in damage mechanisms. So it is, let's say, very crucial to understand what you are going to put in your plants and how the plant react to these changes in the damage mechanisms, because they can increase very much. So it is very important to have an accurate study, and we have some tools. We did some tools also implementing operating windows that an API, according to API, and this is very useful to us to try to predict how damage mechanism will where they will go and how much they can increase. As for people, we still obviously have to put everyone in, because obviously not immediately everybody can be sure that this is the best way to do.
Yeah, that's good. Yeah, I like I like API's concept of integrity operating windows. It relates to your case study on creep. You know, what range of operating parameters will give you confidence that the facility continue to safely operate, or are you eating into the life?
Yes.
Are you affecting the chance that you're going to have to do maintenance sooner rather than later? Are you going to increase the chance
Yes.
of failure?
Introducing new crude,
Francesco.
for instance, when you
Yeah.
introduce a new crude, it can bring you higher acidic number, higher sulfur number, and they can affect, for instance, sulfidation. And you should know where acidic number will be higher, in which streams, and where sulfur can, because obviously sulfur is not perfectly the same in all streams. Okay, and you should know where the problem will be, and try to evaluate it. Otherwise, you can have very bad results.
Okay, thanks. Francesco, one of the questions from the audience was relating the concept of AI-based predictive maintenance with condition-based maintenance, condition-based monitoring. Is that related with what you're doing?
Oh, very much so. I mean, I don't think you can do predictive maintenance if you don't do, especially prescriptive maintenance, if you don't do condition-based, right? So one of our, one of the ways of going back to the previous question as well, how do we select the type of cleaning? Well, we need to know what's going on in the heat exchanger, and we need to understand where the heat exchanger is going, and what is the impact at the plant level and on the economics. So if we don't do condition-based, if you don't understand what the current conditions of the equipment is, together with the economics around it, there is no way we can select the optimal action to take. So predictive maintenance alone, I don't see that being disjointed. It needs to be condition-based with predictive maintenance.
Great. Thanks very much.
I could also add to Fabrizio, if there is time, just to add to Fabrizio's point on the crudes. And that is something that there was a recent study from, well, not so recent, maybe 2-3 years ago now, from Accenture that was showing how digital is impacting refineries, positively impacting refineries. And I think the two areas that they selected was predictive maintenance and scheduling, which is what Fabrizio is saying. So the scheduling of the oils, I believe, falls into this category. So really the two topics that we're talking here, predictive maintenance and the scheduling piece, are the ones where digital is already seen today as one of the biggest impact, positive impact to refinery customers.
Yes. It has to be carefully evaluated, yes.
Okay, great. Well, let's have a closing comment from each of you. Harald?
Yes, thank you.
What do you think?
So it's not that I want to come across as negative, because I agree with and we have experienced a lot of the same as the others are talking about when it comes to the benefits of predictive maintenance and AI and machine learning. But what we have found is that to succeed with our initiatives, you need to understand how the human and the machine shall interact and how they should understand each other. And that means that the human has to understand, as a humans, we have a tendency to trust pretty things, pretty dashboards, pretty graphs, pretty screens. And so it is very easy for humans in the loop to trust a not so good AI machine learning system. And you have to be sure that the humans properly understand what the system is doing. And as I mentioned before, AI and machine learning can make that link to what the system is actually thinking or doing, a lot more opaque, and that gives it, and that makes it more difficult to be the human that is supposed to be resilience for when you're moving outside what the system can do and cannot do.
Thanks. Renata, should we be optimistic? Are we doing the right things for predictive maintenance?
Yes, we are. I really liked Harold's comments also, because I think we should be optimistic, but we also should acknowledge that it's a long journey. And sometimes I joke that there might not be a destination because things keep moving, technologies keep improving, things that we are using currently, they will change and have new versions. So I think it's the constant learning and continuous improvement should be the message. We will always be dealing with technology, and regarding the beautiful dashboards, this is absolutely true. And one of the challenges is getting non-programmers to not be scared when they see a piece of code, because there's a lot to learn from there, but people are used to more beautiful, user-friendly screens and dashboards. But maybe the future will be in the codes and will be not so scary anymore to a lot of us.
Thank you, Renata. Deepika, do you think with all these tools at our disposal that we'll be able to play our part in the clean energy, the energy transition? Are these going to help us?
Yeah, so AI is definitely of value. Like we said, human in the loop, having human in the loop is also equally important. But with AI going more and more mainstream, we see that it is not, the conversations are not just about the underlying algorithms anymore, right? It's also about the complete end-to-end development, deployment. And we see the increased usage of industry standards like CRISP-DM for building the end-to-end data pipeline, and also AI ops frameworks like that of MLflow, which is provided by Azure, for maintaining, monitoring the data and the model drift in production post deployment. So these trends are definitely on the rise, and they will grow in the near future as well. But definitely, it's a combination of the data and the domain knowledge which is going to click.
Great, thanks. Fabrizio, you've got all these good tools, got all these great algorithms, fancy screens, dashboards, and stuff like that. Is this helping you make your refinery be safer and capture more value?
I hope so, and I have to say that I think that it is possible. What I think is that we have nowadays, thanks to all technology progress, the opportunity to do much better than before. And we should be convinced in using these technologies and obviously using our brain to do the best possible. But we have also to convince people that work with us that this is the way, the right way, let's say, what we should do for the future.
Okay. Last comment from you, Francesco. What do you think about all this? Are we headed down the right path?
Well, I think that we are. I'm quite optimistic about it. I think people in the plants, for some reason, they were when they cross the refinery or the chemical plant gate, they forget about what they do as a consumers, right? With the consumers, we always want the new iPhone, we want the new slick car and so on. When we go in the refinery, we're happy to work with, and I don't know how many real pretty dashboards are out there. I've not seen so many, to be honest with you. I've seen plants, very big plants being run on Windows XP, but we have not anymore, of course, but we do have there is a disconnect. I think that's quite recognized. There is a disconnect between the behavior of the operators and the engineers as consumers, and when they go into the refinery. Of course, we need we have the safety culture, which is the most important one, that which we should take outside the gate of the refinery as well. But I think we should bring from the outside. We should bring the more technology savvy part of us, where they're more used to the technology. They're more used to interpreting the data. The human factor. It's always important because yes, we have the dashboards. We can provide KPIs, but interpretation of the data is always up to the users, right? So I think, especially in the past couple of years with the pandemic and everybody getting more into the digital world from a personal point of view and from the work point of view, I think things are actually changing. I remember when refineries were air gapped against, with outside world, and you had to call the people on the phone because they did not have, internet connection speed big enough to be able to have a proper conversation. So I think things are definitely moving in the right direction. I think we should now accelerate the path, and the culture piece, as we have been discussing, has a lot to do with it.
Yeah, thanks, Francesco. Yeah, that's a good reminder. There are certainly some new refineries being built today, but there's also a lot of brownfield situations out there, and not all the control systems, not all the software systems are up to all this. So, a good challenge for our industry is we've got all these technologies and tools to help the operators, to help be safer, to help react to changing crude slates, to capture more value. How can we merge this new technology safely and effectively into brownfield facilities? And it is a challenge. So we can have the fanciest system in the world that we want, but if we don't have a way of getting that to the fingertips of the operators, the decision makers, the people that are setting up the equipment, it's not going to work. So I want to thank all of you. It's been a great panel today. Thanks for sharing all this. Thank you for your time. We didn't get to answer all the questions from the audience, but I think we gave it a good shot. So thanks, and everybody stay safe. Take care. I hand back to Adam.
You gave it a great shot, David. It was brilliant, fantastic. I love that panel because predictive maintenance has so many different opinions, and I think a lot of the comments made by the panelists really broke that down. It was interesting to have different views on this. It's great to have an actual refinery on there in Fabrizio because that sort of gave a slightly different perspective to maybe what Francesco was saying, and then obviously Deepika from Honeywell, and similarly Renata from Braskem as well. And Harald gave a little bit more of a technology overview of that. I love the comment I think Harald made about it's all about data. You've got silent deviations, which changes the functionality of equipment. It shows you how you need to get your ducks in a row when you sort of operate things like predictive maintenance as well. He talked a lot about the richness of data. I like David's comment about the augmented humans. We all hear about augmented reality, but we don't hear about augmented humans, and I think that made me chuckle a little bit. But also, again, we talked about cultural change. I think it's a lot of technology integration is about the let's say the adoption of cultural change, and I think that's a big key. I think Fabrizio was talking a lot about it's great to have it, but you need the culture to also buy into it as well, your refinery to buy into it. So that's a really good comment. I couldn't believe the stat that David said about 80% of maintenance is done either too early or too late. So it's quite a waste. And obviously predictive maintenance should accelerate the appropriate decision making on that. So, and one final point, I think we probably have that mentioned more and more. It's legacy data. I think we talk about. I think it's Francesco that was talking about the data. Obviously, going forward, it's a different proposition with the downstream industry. But I think a lot of these legacy assets, old assets, have very old equipment, and you sort of have that conundrum of either modernizing that plant or starting from scratch. So there is a lot of legacy issues you've got to deal with, and lots of legacy data, which is not easy to deal with as well. So brilliant panel, absolutely fantastic. I have to leave it on one thing, that I love the last comment I think made from Fabrizio, that technology gives us the opportunity that makes us better than before. Brilliant comment, really simple comment, but a brilliant comment. We're now on to our opening presentation of the day. It's done by Horea Orenstein, who's VP Business Development of Loomis Digital, who are our senior technology partner for the event. Fantastic company. And he's going to be presenting on the new paradigm for a transformed future downstream sector. So over to you, Horea.